Hey, welcome everybody in Java. Thanksgiving coming up soon. So let's dig into chapter 9. Don't panic about the advanced part of the arrays. It's not so bad. What we're going to cover is we're going to talk about bubble sorts and insertion sorts, two-dimensional or multi-dimensional arrays. You'll see what I mean. That's different than parallel arrays, just so you know. We're going to use the arrays class, the array list class, and even create enumerations. Wow, right? So first, sorting. This is a really common process that happens in coding. And we want to, for example, let's say we type every single first and last name in from the city of Lynchburg, about 85,000 people. Well, then we want to sort it because it's a lot easier to find somebody when it's sorted, right? So how can we take that array that contains all of those names and put them in a logical order, let's say by last name? If they have the same last name, how do we then maybe sort them by middle name or first name, then middle name? For example, in Lynchburg, we have a lot of Martins and Overstreets and Oranges. So with those common names, you know you're going to have a lot of common first ones. You can either put them in ascending order. That means it has the lowest value. Remember the ASCII chart that we did a few weeks ago? Or the descending order. In other words, we go largest to smallest. And this could be inventory numbers, all kinds of different IDs, and so forth. So now there is the simplest possible sort. If you have two values that are out of order, let's say we had val A was equal to the number 16, val B is equal to the number 2. We could take val A, assign it to a temporary value, assign val B to val A, and then the temporary value is assigned to val B. You see, why are we doing all this? Well, the 16 would go to the temporary value for a little bit, and then 2 would come up to be earlier, or if we're sorting lowest to largest. And then 16 would be assigned to val B. So now val A is 2 and val B is 16. They're in the order. So you can do these very simple sorts. But obviously, if we have, 85,000 people in Lynchburg or 330 million in the United States, this is not going to work so well. So we're going to need something called a bubble sort. You continue to compare pairs of items and then swapping them out of order. So why is it called bubble? It's kind of like the small bubble bubbling up as you swap to the top and the big ones, let's say, going down to the bottom. So the smallest items bubble to the top of the list, eventually created a sorted list. So let me show you this code here. Now, before you watch this explanation, go grab a piece of paper and draw this little table that I've drawn down here and do it as we go through, or it probably is not going to make a heck of a lot of sense to watch me do it. So this is a bubble sort. It looks simple, but a little confusing. I want you to understand how it works. What we're trying to do is sort these numbers, and here's the initial numbers. Although this array, some nums, could be anywhere from, 4 numbers to thousands of numbers. So this same double for loop would work, or nested loop as we call it. So let's start off. We have 2 loops here. This would already be declared before this begins, this int sum nums. And I've drawn a little table here saying in the 0th location of the array of sum nums is the number 8 right now. In the 1 position is the number 4. In the 2 position, the number 2. In the 3 position, number 9. And we're trying to sort these. And let's see how it sorts these, because I don't want you just to plug in how to do it, or you're not going to understand a lot of the assignments. Understanding why is important here. So the reason we have 2 nested loops, we have a nested loop right here, is this is going to help us, iterate through all the numbers enough. So at first, A is obviously equal to 0. and B is equal to 0. So far, so good. And notice it's going to keep on going while it's 1 less than the array. Now, right now, the array has 4 elements. 1 less, it's going to go to 3. But as you know, that will go from 0 through 3, which will take me through every element in this array. So first, let's see what this if statement does. If sumnum sub b, which is 0, okay, so that's talking about this number 8, is greater than sumnums b plus 1. Now, b is 0 right now. So what can we do? It'll be 0 plus 1. So what this is doing right here is it's asking us if 8 is greater than sumnums b plus 1 is 0 plus 1, so the 1 position. Basically what this is saying is 8 greater than 4? Okay, well, everybody agree that's true, right? So because 8 is bigger than 4, we're going to go inside the if statement braces. So sumnum sub 0. Now we have another variable over here. Let's call it temp. Make this a little bit bigger so you don't need glasses before we're done. Excuse the automatic capitalization of OneNote. So here's temp. So what temp is going to hold right now is the value of sumnum sub 0. Remember, b is still 0. So sumnums sub 0 is 8. So right now, in the computer's memory, which we would have had to declare temp somewhere. So while we were declaring variables here, we'd probably have int temp at the beginning somewhere, lowercase I obviously. And now we have temp equals to 8. So it's kind of like holding the number temporarily for us. And don't forget, the computer always looks at the right side of the equal equation. So let's go here on the next line. Sumnums b plus 1, so 0 plus 1. So this is looking at sumnums 1, which is the number 4, is now going to be assigned to sumnum sub 0. So in other words, 4 is going to wipe out the 8 and go here. Wow. Now, let's take temp, which is presently 8, and put it in the position of 0 plus 1, in 1 position. So the number 8 is now going to come to the 4 position. What these 3 lines basically did was swap them. Got it so far? Now, what are we trying to do? We're trying to go from lowest to highest. And we're not done, clearly, but we're in better shape. We were 8,429, now we're 4,829. So far, so good. So now after this if statement, it comes out to the inner loop. We have to finish the inner loop before we go back out to the outer loop. So now b is 1. It's still less than, 3 here. So we're going to keep on going. We incremented it by 1. And now let's see what's going to happen here. It says if sumnum sub, now b is 1, if sumnum sub 1, so in other words, if 8 is greater than 0, now it's not 0 anymore, it's 1, so 1 plus 1 is 2. We're now comparing the 8 and the 2. So the question is 8 greater than 2? So is it? Yeah, it is. So we're now going to come into these 3 lines. Sumnums sub 1, which is 8, is going to be assigned to temp. Oh, good, already is. And then 1 plus 1 is 2. Sumnum sub 2 is the 2. Going to be assigned to sumnum sub 1, which is right here. So now we have 2 2s. We're now going to take the temp, which is 8, and assign it to this 2. Do you see it starting to bubble through? So now we're getting there. We come back up. Now b is going to be equal to 2. 2 is still less than 3, so we've got to continue on. So we're now going to compare sumnum sub 2, the 8, and see if it's greater than 2 plus 1. What's in 3? 9. So everybody, is 8 greater than 9? No, 8 is not greater than 9. So we're not going to do this at all. Let's come back up. Now b is going to equal to 3. Can it be 3? Well, let's see. Is B is now 3. Is B less than 3? No. So we're not going to go into the inner loop anymore. So we're going to come back up, go back to the outer loop. Now A is 1. It was 0. 1 is less than 3. So we're going to start on the second time through the outer loop. And now B is going to restart all over again at 0. So let's see what happens now. If sum num sub 0, okay, that's the 4. So let's change that. We're talking about the 4. Is 4 greater than 0 plus 1? 1 is 2. Is 4 greater than 2? Yes, it is greater than that. So we're going to go inside of here. Temp is going to be assigned sum num sub 0 or 4. And we're now going to take 0 plus 1, 1, the 2, and push it over into sum num sub 0. Okay, so the 2 goes here. The last line of the if statement, temp 4 is now assigned to 0 plus 1 or sum num sub 1. Is the 4 is going to go here. Guys, this is, now I know what you're thinking. We're done, Corinne, we're done. Well, the program's not done. So therefore, it would continue to go through again. It would then say, now B is 1. I'll show you in just a little bit more. I think you're getting the idea now. If sum num sub 1 is 4 greater than 8. No, it's not. And then it would come around and is 8 greater than 9? No, it's not. So it finally end. And now our array is sorted. And you have to think, how about if I wanted it in reverse order? Well, that would be kind of easy. We could probably just flip around this less than right here to greater than. So this is a simple way to do that, but I want to take you now back into the next page. This one is a little more efficient than what we just did. The only difference between the programs that we're looking at is they're going to have this comparisons to make equals sum nums dot length minus 1. What it's going to do is every time it goes, the outer loop, opens, we go through the inner loop so many times, it comes back out, it's going to subtract 1 from the array because we don't have to keep going through over and over again. So now stop your video and go back through this program with my same array to see how that would make it so much more efficient because we don't have to go through as many times. And why do we care to make it more efficient? Because the program would run faster. And for example, when you're trying to calculate your Amazon cart, you don't want to sit there forever. So efficiency is important. Now, we made the first example using an array of numbers, but how about if we were talking about an array of objects, let's say strings? Well, you would sort them the same way, but the major difference is don't forget you can't say necessarily just greater than or less than. You have to use dot compare and some of the same things that we sort by the object field. So now I want to show you a bubble sort demo with a little more numbers. So you can see we have some nums now 77, 65, 51, 43, 32, 29, not at all sorted. We do want to go from the smallest to the largest. And if you look around, except for this new comparisons to make, which makes it a little more efficient because it doesn't make it go through all the way to the end, because once we have them in order, you don't have to keep on going. But notice what's different about this program is line 19. We're going to call a second method called display. And I know some of you that trips you up, so I wanted to show it to you, where we're passing the array sum nums down each time we finish the inner for loop. So we do the outer loop and go round, 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 inner loop, then do display, come back around, do the outer loop, inner loop, inner loop, inner loop, then go back to display, So we're passing the array down. And if you remember, you pass an array with just its array name here, no brackets. But when it comes down here, we tell it it's an integer array called sumnums. And we're passing it a plus 1. Let me show you what that is. A is the outer loop, so 0 plus 1. We're going to be passing down 1 the first time through the outer loop, 2 the second time through the outer loop, 3. So what is it going to do down here once you get passed down? So we're going to say it's iteration 1, iteration 2, iteration 3, and show how the numbers are bubbling up. Let me go ahead and run it. So when I run this program, this loop is just going to show us where the loop is each time. So let me make it a little bit smaller so you can kind of get the big picture here. So after iteration number 1, remember it was comparing 77 and 65. So it is showing you after iteration number 1, don't forget it did a lot of swaps. It moved basically 77 to the end because it first said is 77 greater than 65. It was. So those two swapped. Is 77 bigger than 51? It is. So those two swapped. Is 77 bigger than 43? So those two swapped. Is 77 bigger than 32? Those two swapped. And is 77 bigger than 21? Those two swapped. So do you see that basically all that's different the first time we go down to the display method is 77 has bubbled to the top, basically, to the end. So everything is in order except the 77 because it got moved to the end. So that's why it says iteration 1. And after it finished this, it does a blank line, comes back up, subtracts 1 from comparisons to make. Remember, it was 1, 2, 3, 4, 5, 6. 6 minus 1 is 5, so that's going to be 5. So it makes it 1 smaller, 4. So now we come back up, and now we're going to have the number 65 is in the front. And now 65, we're going to compare it to 51 and 43 and 32 and 29, and it gets moved all the way to here. And you can kind of see then 51 gets all the way moved. And let's see, then 43 gets moved, and then 32 gets moved. So hopefully you're understanding how this sort is. And look at the final one. After 5 iterations, we finally have the loop sorted. And again, these could be any data type here. Pretty cool. Next, let me show you another type of sort. The other one was called a bubble sort. This one's called an insertion sort. And the reason that it enables you to look at each list item one at a time and move items down if the tested element should be inserted prior to other elements. It's similar to the bubble sort, but it's a little different. Let me show you. So let's look at this program. It almost looks the same, but notice, we have some while loops instead. We have our same set of numbers. We're going to say A is 1. You'll see why. So we're going to see while 1 is less than the length of the array. 1, 2, 3, 4, 5. So while 1 is less than 5. So we're going to keep going through this until we finish the array. So that's pretty simple. So first, we're going to look at sumnum sub A, which, of course, in this case is 1, not 0. Careful. So we're really looking at the number 85. And we're going to assign 85 to temp. Now, we also have B. We're going to subtract 1. Right now, A is 1. 1 minus 1 is 0. So now the second while loop is going to go while B is greater than or equal to 0. Well, it is 0. Don't forget this means and. Sumnums sub 0, in this case 90, is greater than 85. So is 90 greater than 85? Yeah, it is. So we'll go inside this while loop. And sumnums sub, right now, B is 0. Well, sumnums B sub 0 is now going to be assigned. So in other words, 90 is going to be assigned the location of where 85 is. So 90 has now bubbled up to 85. instead of saying bubble up, I should say it's now been inserted in its location, so we don't get confused with the bubble sort. Now this line is kind of confusing. Let's look at this. Negative, negative b. We all know that's a decrement. Now b right now is 0, if you remember. So what's 0 minus 1? Well, it's negative 1. You say, why do I have negative 1? Well, that is going to come back up. Well, is negative 1 greater than or equal to 0? Well, no. So it's stopped this very quickly. So now the temp value, if you remember, 90 was inserted where the 85 is. 85 is the temp right now, is now going to be assigned, temp was 90. So now it's going to be assigned 0 plus, negative 1 plus 1, 0. So it's going to be assigned here. So now we have 85 is inserted there and 90 was inserted there. It still is now. So now A becomes 2. So what's going to happen through this process is, once again, all the swap out, but it's just the same kind of type of sort, just using a little bit different methodology. You say, which one should I use? Well, if your assignment identifies insertion or bubble, use that, but use whatever one you're more comfortable with ultimately. We'll come back and do the second video next.